Okay, I'm almost done. I replaced all the paper caps that I could, except for those two that are so inaccessible. I then moved on to the electrolytics. I replaced 3 out of the 5. I got the multi-suction guy down in here, 2 new caps, and the main filter cap here, which just leaves this 2-suction cap. What I've been doing is removing all the leads going to the cap, keeping them grouped. Like in this case, it looks like there were 3 leads going to the negative and 3 to the positive. You want to keep those straight because if you mix them up, bad things could happen. I then took a terminal strip, and in this case I broke off the end, just leaving the center 3 terminals. Soldered the center one to the post coming out of the cap, just to anchor it. I didn't connect anything to this, just to keep it stable. I then soldered the new cap to the outer terminals and hooked up all the wires back. So it's pretty stable, it's in there pretty solid. And it's quicker and faster than removing the cap and restuffing it and so on, like you saw in my Philco 60 series. So I just need to do this guy and reinstall a power cord, and then I'll do a simple check. There is no power transformer on here, there's no transformer to check, but what you can do is hook up an ohm meter to the power cord. And what you should measure when you turn the switch on is the resistance of this resistor, then this filament, and so on, and this resistor going back. If one of the tubes is bad, it'll be infinite, or if there's a short somewhere, it should be a lot lower than you would expect. This has a 130 ohm here and a 30 ohm here, plus the tube resistance. I'm not quite sure what the cold resistance is, but the resistance better be higher than 160, certainly, because that's the 2 resistors, and then I'd be adding in this. And if that checks out good, I will hook it up to a dim bulb tester and try to power it up. Okay, I finished wiring in those 2 new caps. While I was at it, I also replaced that 150 ohm cathode bypass with a 390, which is a lot closer to the schematic indicated value of 400. And here, it's hard to read, but that's supposed to be a 20 ohm flexible resistor. And what I found in here was 2 put in parallel, which measured about 70 ohms total. So I replaced that with a 20 ohm. I've got my meter hooked up to measure resistance, going to the power cord. Oh, I put a new power cord in. So when I turn it on, I should measure that resistance. Just going right through all these tube filaments. Unfortunately, when I turn it on, I'm measuring infinity. So what I will start doing is, here's one end of the power cord, and I can simply start measuring from there through the various points. I already measured this power resistor and it measured good, so I assume that's okay. And that's both this section and that section. So that one of these tubes has a blown filament, or maybe it's just loose in the socket. We'll see. I traced through all the tube filaments and they all check good, which got me all the way back to this point, measuring about 194 ohms. So that's these 2 resistors plus all these tube filaments. So everything's wired good in series. That's about the resistance I was expecting. However, when I take that over to the power switch, the 2 lugs down in here, one lug is measuring 195, but the other, which is what the power cord goes to, is infinite, no matter what position I put this switch in. So it looks like I have got a blown power switch. Not what I was hoping to see, but in the meantime, I can simply short this switch out to force it to be on. And in the meantime, well, I'll get the radio working like that, and once it is, I'll see about either dissecting this one and maybe fixing it, or hunt around online for replacements. I've shorted out the power switch, the radio's always turned on. I also pulled the speaker from the cabinet and reconnected it, following the reference photos I took. Speaker itself's in pretty good shape. There's a few minor tears here and there and some repairs that weren't done very well because the glue seems to have dried out and the tears are just as torn now, but otherwise seems to be in good shape. Got the power cord plugged into a dim bulb setup, isolation transformer. So here goes. Well, unfortunately the light bulb is on. I wouldn't say it's full brilliance, maybe 50%, so something's not quite right. And I do not see the tubes lighting up at all. So, time to do a little more troubleshooting. First thing I want to do is pop a tube out, because if I do, that should break this chain and there should be no current flowing. So I just pulled out the rectifier tube. Now with that out, if I turn it on, okay, bulb doesn't light up, so I've broken the circuit. So that's weird that by taking one of these tubes out, I'm breaking the circuit, yet with the tube in it, it's acting like a dead short amongst these filaments. So my first suspect is that this 25Z6 rectifier tube has a short inside the tube. So I'll check that on my tube tester. Let's see what's up. Okay, I've got the tube in my triplet 3413B tube tester, and the tube is lighting up nicely, so the filament's certainly not a dead short. Let's see, go through the various tests here. No shorts. I think that is indicating there's a short on pin 4. The way this tube tester works is the numbers that are in bold, you leave them in the position. So for example, the test 25Z6, test 1, you use the numbers in the first column. So A3, B25, C-low 24, up 3, which I have, and then down 4, 7. To test for shorts, the ones that are not in bold, you flip to the opposite position and look for the light to light up. When I flipped 4, the light lit up. So there may very well be a short in this tube. I'll do the second test here, which is up 5 and down 7, 8. And 5, no shorts. And 8. 8 has a short. So I've got to go digging through my tubes and look for another 25Z6. Well, it took a while, but I dug through the stash of tubes I picked up recently and finally found a used Hytron 25Z6. That does not have any shorts. So before, when I was flipping this lever 8, I was getting a short. No shorts. Test good. And same when I did the other test. So pop this in the radio and let's see what difference it makes. Now that I think about it, I bet the tube shorted out and that's what took out the power switch. That's a problem with these early indirectly heated cathode type rectifiers. I know the 6X5 is really notorious for shorting out, and maybe this one is too. Because remember, this rectifier is rectifying the AC line, so if these elements short out, that's like the full line potential, you know, burning out through the tube and through that power switch. So let's see what difference that made. Huh. Well, didn't make any difference, so there's still something that's not right. Well, no, I take that back. No, the tubes are lighting up. It might just be the wattage bulb I'm using is a little too low for this type of radio. So it's only a 60 watt bulb, and the radio is drawing about 60 watts. You would expect this to be about half brightness under normal operation. And how's that for proof? It just started playing.
Thank you. Well, my comment is, it's a good idea that everyone
Volume
should
controls.
own at least one firearm.
I don't even have an antenna hooked up. I'm on the AM broadcast band right now.
Obamacare on that same premise.
Yeah, I'm definitely picking up a few stations. Even without an antenna. No, dial light's not working. Wondering why. So that bulb might be burned out. I'll have to check on that. Well, like the whole point of this video was, you don't need to use all this stuff to get a radio working. Don't have to rebuild the caps, don't have to repaint the chassis or any of that. Replace the paper caps and replace the electrolytics. Make sure the tubes are good, like this rectifier. And the one thing you should really rig up is one of these. Because if I didn't have this with that shorted out rectifier tube, I would have probably popped a circuit breaker, blown a fuse, or something, and this radio would have really gone up in smoke. Let's try the shortwave bands. Again, I have no antenna hooked up, so. Well, I do happen to have like a 20-foot long piece of wire handy, so I'll rig that up and see if the shortwave band picks up anything. I just sort of turned the radio off. Well, that's not going to work. So I think that's going to be the big remaining challenge, is to try to fix that power switch. I got that rubber coating off and replaced the light bulb. Now that you can see how that tuning indicator works. I stretched out my antenna more, and we can get more shortwave stations. And AM's working fine. So there you go. Total elapsed time maybe 5-6 hours. Would have been less without all the fun challenges along the way, but I guess that's to be expected. So a few simple things to repair the speaker cone a bit. I could clean up the chassis a little more. But something I should really do that I'm going to save for another video is talk a bit more about how to make this radio safe. Like adding a fuse, replacing this bleeder resistor network, which is, it gets pretty toasty on the side here. It's that big power resistor that's burning off the excess voltage because these two filaments don't add up to 120. There's some ways you can do it using capacitors or diodes that will generate far less heat and do a nicer job than this does. But otherwise, yeah, it just goes to show you that you can get a radio working fairly inexpensively, fairly easily, without having to use a lot of fancy test equipment. I hope you enjoyed this video on restoring a Philco 37 611.